Hi guys and girls on YouTube, welcome to my channel. In this video we're going to be looking at a vintage 2-valve little oscilloscope. Now I think this is quite a rare item. It's not rare because there's not many about. I would imagine there's plenty about. In fact, I've got another one very similar to it. Over the years different versions were produced, and I'm led to believe later on they actually produced a transistorized one. So what makes this item so rare? Well, I think it's rare because not only do I have the original circuit diagram and all the building instructions, we've also got the course notes, because this oscilloscope was actually advertised in a lot of radio magazines, and it was the British National Radio School. It was a course that you did on electronics, and the first thing you did was build an oscilloscope. Now I've actually done a video on one of these before, but I didn't have all these original documents with it. Now this doesn't actually belong to me. It was given to me for repair by one of my good customers, Andrew, and he said his dad made this when he was young, and he did the electronics course using the oscilloscope, and they very much like to see this working again. Now hopefully later on today Andrew will be bringing his dad in, who's in the 90s, and perhaps he can fill us in a bit more information that I don't know. But let's just stop the camera and take a quick look. Right, so that's the little scope in question. Now I'm told it no longer works, and I've pulled out a couple of magazines here so we can have a look. This is dated Practical Wireless 1972, Everyday Electronics 1976, and if we turn over and mark the pages, that there is the scope in question. Now what you did first is you build that, then you learn to understand the diagrams, and then with the notes provided with a course you carry out 40 different experiments. So as you can see, that's it in the magazine. Now as far as I know, they didn't come with a case. This is something that's been homemade. So let's just slip it out of the case, and then we'll take a quick look. Right, so this is the inside. As you can see, for its age, it's in very good condition. There's a pair of wires hanging down here. Now they seem to be, if we look at the back of the scope there, there's been some sockets added, and there's another board in there. I would imagine them two wires go to power that transformer from the mains. Now I don't know what that is, because it's not part of the kit. I don't think it's part of the kit. It doesn't mention it. I would imagine it's some sort of calibration circuit. So we'll take a look. As you can see, this looks like a piece of tin foil, where they should have a proper mu metal screen, which stops the beam being deflected by either the transformer or any external magnetic sources. So that doesn't look, that looks a bit wrong to start with. Let's just take a look at the front panel there, and then I'll rotate it round. That there would appear to be high voltage multiplier, because I would imagine these will run probably 700 volts, this tube, the final anode voltage. So let's turn it on its side and have a look underneath. EF80 there. I can just about hold it while we look underneath. There's a couple of electrolytic capacitors there, look like the electrolytes leaking out, so they'll need to be replaced. I've also, these carbon resistors are notoriously unreliable. Even when they're brand new, they just change value over the years. Now I've checked, I've run a meter around these, I've checked all these. I actually found one there which had risen in value, so I've changed that first. It was a 47k. Get the old one there. It's marked 47k, but the value I measured on it was 243k. So I've just replaced that to start with. We're going to reform the main reservoir capacitor, and then we'll switch it on and see what happens. Right, so I'll plug the scope in. The valves are actually lit up, but we don't have any deflection, any trace on the screen. Now, what I thought was the high voltage multiplier, that's not correct, because now when I look at the diagram, it doesn't actually have a high voltage multiplier. We've just got 2 windings on the transformer, 6.3 for the heaters, and 500 which powers the rest of the scope and the screen. So the HT rail for this is going to be a little less than 500 volt. Now I've measured this point here for the 500 volt range, and we only have 285 volt, which is bad news, because there's a 4.7k resistor there, so the current's definitely not flowing this way. The output from the transformer's low, which is bad, because I've left it on a few minutes, and I can hear a crackling noise coming from this transformer, which is also very hot, and there's a smell of burning enamel. So obviously the transformer's got shorter turns, probably as a result from being in a shed for years. So what I'm going to have to do, I don't have one of them transformers. We're going to have to find something that'll do the job and order it in. So I'm going to stop the camera here, but hopefully we've got Andrew bringing his dad in later on, so we can probably get a quick chat with him, and then it'll be at least a week before I can get a transformer, and then we'll come back to it. Alright guys. Right guys and girls, so nearly 2 weeks has now passed since I started this video. Due to unforeseen circumstances, Andrew was rushed into hospital on the day he was supposed to be bringing his dad up, and but fortunately he's made a good recovery, and also the transformer's still not arrived, and when I contacted the company, it turns out they don't keep them in stock, they actually wind them to order. So we're 2 weeks later on, and Andrew's due with his dad in a few minutes, so without any further introduction from me, because as you can see I'm not very good at making videos, I'll pass you straight on to Andrew and his dad.
Just say this is the...
Right, okay guys and girls, so here we got Andrew's dad, the person who built this oscilloscope, and we think it's about 1976, same as the magazine.
And this is responsible for getting me into electronics for the past 40 years, but not valve technology, which is why it's handed back to Michael. Thanks, Michael.
Okay, so as soon as I fixed it, I'll fit the transformer, and then we'll do the next part. I'll show you working.
Brilliant. Thank you very much.
Alright then. Okay, thanks for that. Right, well the new transformer's arrived, and I've tried it and it works okay, but we run into a big problem. Because it's 80 milliamp and this is only 50 milliamp, it's far too big to go in, put it side by side. So what I've had to do is I've had to take this piece out the back here, and the plan is to, because the transformer won't go on the chassis because this is in the way, the plan is to put some wooden supports on there and hang the transformer in the back upside down. So let me just see if I can show you this on the camera. That's going to go in there like that. And then see that space there, I'm going to put a piece of wood there, so this transformer will
hang upside down in that space there. And then what we're going to have to do is just run some wires and perhaps have a plug and socket. So yeah, that's the progress so far. Right, so that's the general idea. The transformer's now hanging upside down on these 2 blocks of wood. All we've got to do is just get all these wires connected, and I think what I'll do is I'll bring them out to here and perhaps have a plug and socket where you can plug in here, so you can actually still remove the oscilloscope from the front and leave the transformer in the back. Right, so that's where we're up to now. The wooden blocks are glued in, and I've also changed the 2 capacitors that were faulty. We turn that upside down, so you've got 1 cap there and 1 cap there. I've also decided to abandon the idea of a plug and socket because there's far too many wires here, so I'm just going to hardwire it in on quite long leads so we can actually pull the oscilloscope out the front, so it can still be repaired if anything goes wrong with it in the future. But that's the progress so far. So while we're waiting for the glue to dry on the wooden blocks, which will probably be tomorrow, let's take a quick look at some literature that's come with oscilloscope. Well, earlier on I mentioned the mu metal screen didn't seem to be right. I've actually found this in the instruction book, and it turns out that what I thought was tin foil did actually come with a kit, and that's the instructions for it. So over here we have Principles of an Oscilloscope, British National Radio School. Let's have a look here. Some more literature. Now this magazine was actually in with the literature, so I'm presuming this is the magazine it was bought out of. Now if you notice here, it doesn't mention any prices. Now here's an interesting thing I've just noticed. Here's the introduction, and it's actually dated 31st of the 12th 1973. So obviously it wasn't bought out of the book. I assumed it was, but if we take a look down here, this seems to be an introduction to this this course. So I'll move very slowly, and then you can read it for yourself, or you can even pause the video. And if we move down there, it says your student number is S/276. Your tutor, M. Brandon. But I've actually noticed in the back of here something even more interesting. There's actually a price list which was never published in the magazine as far as I know. So let's have a look. Right, so here's the price list under here. Here we go. Order form, Practical Electronics course, the British National Radio and Electronics School. I wish to purchase the full course of 18 steps by cash, and therefore enclose the fee of £70. So this was £70 to do this course, including the oscilloscope you build yourself. And I would imagine in 1973 that was an awful lot of money. Now there's a strange thing here I've noticed. You can actually pay in instalments. You can pay 1 step at a time, £4.50, 2 steps £8.75, 4 steps £17, Half the course, £37.50. You can choose whether you want to pay weekly, fortnightly or monthly, but this is something I've never come across before. Method B, cash on delivery. You pay the postman each time he delivers a step. I find that a bit odd, but perhaps that's what they did in them days. So there we go, the whole course was £70, or you could pay in instalments. So that's the circuit diagram for it. Also here you can see some more building instructions. This is concerning the metalworking, where all the different parts go. Now what you will have noticed is there's rather a lot of these circuit diagrams come with it, and I was a bit puzzled at first why they supply so many circuit diagrams, but I can see now why there's that many, because what you do, you put so many parts in at a time and you mark them off on here which parts you put in, keep a record, and then you'll move to the next sheet and you'll put some more parts on. So if we look at this one at the back, somebody's drawn on this all the different parts have been fitted, and that's why there's so many different diagrams. You do a bit at a time and mark it on there, but eventually you end up with a diagram like that that's pretty much unreadable. Now this bit here is a very detailed explanation of how all the scope works. It's broken down into stages by stages. It also tells you how all the resistor values are worked out. Here's some fault finding chart. And here's a book containing experiments 31 to 35. So let's just turn that over and have a quick look. So presumably these are some of the circuits that you actually made with some components, and then you measured the waveform at different points, I would imagine. And if we move over to this one here, experiments 36 to 40, it's very interesting that they're still teaching valves in 1973. That appears to be demonstration of a valve amplifier. And if we look at here, one valve radio receiver. So it also looks like you built a small radio, and then looking at that there, connect the oscilloscope there, so you're measuring the audio waveform of a one valve radio. So yeah, it's all very interesting stuff. I'll just scan through one of these very slowly. Phase shifting audio oscillator. Let's turn that over and have a quick look at that. Yeah, experiment 39 using an EF1 RF valve. And presumably you powered these, the experiment was powered from the sockets on the front of the oscilloscope. Or it could even be them sockets on the back actually that I didn't know what they were. Right, so what I'm going to do now, guys and girls, I'm going to stop the camera, and then we're going to fit the transformer, and then we'll just finish off the last part of the video. Just take a quick look at this before we stop the camera. Yeah, still teaching valves in there. Right, so as you can see, I've managed to get the transformer in the place I wanted it. We've just got to get the scope back into its case now and get it all wired up. Right, so there we go. That's the finished result. That's displaying a 1 kilohertz sine wave from a signal generator over there. So let's just turn up the Y gain. Now, if you remember, I mentioned these sockets on the back. I didn't know what they did. Well, when I look very closely, I don't know if you can see it on the camera, but it seems to be some sort of precision voltage reference, because that's marked 10 volts, that's marked 1 volt, the blue one is marked 0.1, and the white one is marked 0.01, so presumably that is the ground. So it looks like that's just something that's been added as a reference voltage. But yeah, there we go. Very good result. There's the on and off switch. That's the brightness control as well, that brightness and on and off. Now, as you can see on the CCTV camera, it's snowing again. But this time we haven't had a power cut in the workshop, so things are looking up today. So as you can see, that's the transformer fitted in the back. Now I've got these 2 bits of wood left over. I've already cut this one. I'm going to cut that one, and we're going to put them in the back to cover up the transformer. By the way, that's the 0.6.3 output, the mains input, and the high voltage is on the other side for safety. Right, so as you can see, that's the back covered up. So there we go, everybody. That concludes the video. That is the British National Radio School of Electronics oscilloscope. Back to its former glory. Right, guys and girls, I hope you've enjoyed the video. Please subscribe to my channel for some more interesting things. Alright, switch it off. Many thanks for watching. See you in the next video.